Hey guys. So tonight on the Play Posit, we're going to be talking about sequences. Um, and so we're actually going to start by reviewing some sequences that we've previously spoken and learned about, and those are arithmetic sequences. So an arithmetic sequence is a pattern of numbers, like this one, 19, 22, 25, in which there is a common difference. That is, we're adding or subtracting something to get to the next term, and there is a pattern that exists here. On this question, to get from 19 to 22, we're going to have to add 3. And to get from 22 to 25, we're going to have to add 3. So the common difference here is plus 3. We're adding 3 each step of the way. The other thing we need to know about sequences is we need to be able to find their zero term. In order to find the zero term, we have to follow the pattern backwards one level. And so if we're adding 3 to this each time, the zero term is going to require us to do the opposite. And 19 minus 3 is 16. That is our zero term. Once we have a zero term, 16, and a common difference, 3, we're able to write a rule or a function that will model the situation. So in sequences, we usually use this formation a sub n is equal to, and what are we doing here? We're going to add by 3 some amount of times. So we'll do that as 3n. And we're going to start from the zero term, which was 16. So as I'm looking at this rule, what it's telling me is, starting from 16, I'm going to add 3 some amount of times. In the case of this question where we're asked for the 70th term, to find the 70th term, we simply need to plug in 70. And that's going to give us 210 plus 16, which means that the 70th term is 226. And that's how we work with an arithmetic sequence. That shouldn't be terribly new, but maybe that was a nice little reminder for you. And I'd like you to take a moment right now to try to find the explicit rule, the function, the model that we can use for this function. Go ahead and give it a try. So on this question, our pattern is subtract by 2 each step of the way, which means that going back to the zero term, we're actually going to add 2, and it's going to land on 19. So for our rule, we should have written something like a sub n equals subtract by 2 n times, starting from 19. You might have also written this in this form, f of n equals negative 2n plus 19. And that means something very similar. Usually when we're talking about sequences, we go ahead and write it this way. When we're talking about functions, we write it this way. But really, they mean the same thing. So using this rule, I'd like you to find a 60. What would the 60th term be? Go ahead. All right, so to find a 60, we would simply plug in an input of 60 to our rule, and we'll get negative 120 plus 19, which is negative 101. The 60th term in this pattern will be negative 101. So that's a review of what we've learned so far about sequences. And what I want us to do now is see where we're headed. Like, where is this going that's new? So we've got some new information on this page. And I'd like you to just kind of think about what is the pattern that's happening in this particular question. So this one is different in that the pattern is no longer an addition or subtraction pattern. And there is a pattern here, though. And so if we really kind of look at it, we'll start to see that the way I get from 5 to 15 could be plus 10. But if I add 10, that's not going to be consistent on the next one here. This number would have to be 25. But there's another way to get from 5 to 15, and that is to multiply by 3. And if I multiply by 3 from 15, I get 45. So there is a pattern here. It's just a multiplication pattern instead of an addition pattern. So let's go ahead and go back and find that zero term again. Same way as we've done before, we're going to do the opposite operation. So instead of multiplying by 3, to get back a step, we're going to have to divide by 3. My 0 term is going to be just 5 over 3. So what is this going to look like as a function? What is this going to look like when we start to try to write a rule a sub n? And we kind of have to think about this a little bit. We're starting at 5/3, and the way that we get the next term, if I wanted to get from here to 5, I'd have to multiply by 3. And if I want to get to the one after that, I'd have to multiply by 3. And the one after that, I'd have to multiply by 3. In the arithmetic sequence, we were adding and adding and adding. And now we're multiplying and multiplying and multiplying. And do we have a way of writing repeated multiplication? And the answer is yes. If we want to do repeated multiplication, we use an exponent. So this might be written something like 5/3 times 3 to the power of 3. So in our general rule, we're going to say we're starting at 5/3 because that is our 0 term. And we're going to multiply by 3. And the number of times we multiply by 3 will depend on which term we're trying to go to. If we're trying to go to the first term, we're going to multiply once. If we're trying to go to the second term, we're going to multiply twice. If we're trying to go to the third term, we'll multiply 3 times. And so my exponent here is actually going to be my variable. It's going to be 3 to the power of n. And then, of course, we could use this rule. If I needed to find something like the 10th term, I would just plug in 10 to this rule. Cool. So I want you to take a moment right now. I know we only did one example together, and feel free to rewind if you need to think about this for a minute. But I'd like to see what you come up with for the explicit formula on this question. How can we write a formula here? Go for it. So let's try to identify first our pattern, our common ratio. What are we multiplying by to get from 12 to 24? It's times 2. And from 24 to 48, it's times 2. And we can go back and find our 0 term. And our 0 term is going to be 12 divided by 2, which is 6. There's our 0 term. So when we go to write our explicit formula here, we're going to start with a sub n equals. This is starting at the number 6. That's our 0 term. We're multiplying by 2. And how many times are we going to multiply by 2 here? Well, it depends what we want. If we want the first term, 6 times 2 is 12. If we want the second term, 6 times 2 is 12, times 2 is 24. So the number of times we have to multiply by 2 is going to be determined by which term we are looking for. A sub n equals 6 times 2 to the power of n. So on this last couple examples here, these last 2 questions, let's start here with number 1. On number 1, what type of sequence is this? Is this an arithmetic sequence that has an addition pattern? Or is it a geometric sequence that has a multiplication pattern? Cool. So it's an arithmetic sequence. We have a constant difference here, a common difference. We're adding by 12 each time. Now, can you go ahead and find the rule for this, or the explicit formula for this? All right, so let's see if you got it. Let's go back to the 0 term. 12 minus 12 is 0, so the 0 term is actually just 0 here. And we're going to get a sub n equals. We want to add by 12 for each n. We're starting at 0. That'll be my explicit formula there. We might have just written something like a sub n equals 12n without the 0, and that would have been great. What kind of sequence is the second one? Number 2 here, 8, 16, 32. What kind of sequence is that? Okay, so that one is, this question number 2 is a geometric sequence because the pattern is no longer an addition or subtraction pattern. Now we're talking about a multiplication pattern, times 2 and times 2. If we go back to the 0 term, where will the 0 term be? So the 0 term is going to be at 4. Because 8 divided by 2 is 4. And then a sub n is going to equal what? What will this explicit formula be? All right, so once again, we're just going to get this a sub n equals. We're going to start at the number 4, and we're going to multiply the 4 by 2. How many times are we going to multiply by 2? We're going to do it n amount of times. So my rule is going to be a sub n equals 4 times 2 to the power of n. And I just kind of want us to see the difference here. So I'm going to flip back to a couple of things that we've already done. There's one example that we've already done. And here's another example that we've already done. And I want you to see the difference here. In these patterns where there's a repeated multiplication, there's a multiplication pattern, my rule always involves an exponent. It looks like an exponential function. Whereas these patterns that are addition and subtraction patterns usually ends up, or always ends up rather, in a linear pattern. So we get this y equals mx plus b kind of thing going on here. We want to be able to tell the difference between the two, and we want to be able to write rules for both of them. So hopefully you've taken some good notes, and you can come ready to ask any questions you have tomorrow. Where did you get lost in this video, etc.? I want to get some feedback from you right now, and then we will continue to talk about it tomorrow. So hang out here for just a minute and answer the survey at the end of this video, and then I will see you all tomorrow. Bye.